Okay, let's continue. So let's see where we are in the set of tutorials. So you can click up here and you can see that we're here and we just completed this one. Now we're going to here, creating and removing columns. So creating columns or removing columns. So what does that mean? Well, if we go back to the data set that we created last time with the products and the transactions, I have it here in Excel. So you might say, oh, well, I don't need this column. So how do you remove that in RapidMiner? Of course, we can remove it in Excel just by clicking here and clicking delete, or any column that you want to remove. So that's one thing you might want to do. And another thing is you might want to create a new column. And here, a typical example might be that you might want to create the total. And by total, I mean, so here's a transaction. So here's an example, total. And what do I mean by total? Well, the price was 35.5, maybe this is dollars, and they purchased 4 of them. So the total would be $35.50 times 4. So that would be the total. So of course in Excel, you can just do equals and this times, and remember the times symbol is that, and that will give you the total. And then you can just copy this down and so on to get a new column called total. Now in data science, we think of columns as variables, and we're trying to build a model that takes values, takes certain variables as input and predicts something as an output. So these columns are variables. They're also called attributes. So let's see how we do this kind of thing, creating new columns or creating new attributes or creating new variables in RapidMiner. So we're going to be using the same data sets as before. So we'll put transactions here and products here. And we did this before, join. And we put that here. And then we connect them. So it's very easy to forget to connect things, but you have to connect them when you have this kind of doing data mining in this pictorial way. And the RapidMiner is not the only software that will use this kind of graphic interface like this, or sorry, this kind of pictorial way of doing data mining, but you don't have to use this kind of interface. There are plenty of other interfaces. So we might look at Weka, which is kind of the original source for RapidMiner. We might look at that because they have various ways of doing this. But anyway, we have these 3 squares here. We've connected them, and I think we had to click on this, and then we had to say we want to do an inner join. And then we had to click here. We had to find and identify the left key attribute and the right key attribute, and that was the product ID. So we have to have at least one thing in common in each table. And then we would click apply. Okay, so that's as far as we got last time. Let's just see what they say here. So they say you're almost ready to build your first predictive model. So predictive model or data science model. But first we need to deal with 2 very important operations for transforming your data sets into a format more suitable for training your model. So what they mean by that is just deleting a variable or adding a variable. Then they say the beginning of this process is the same as the previous one, so this part is the same. This is a great opportunity for you to implement what you've learned so far. We'll then create a new data column, i.e. generate an attribute, and then we're going to remove some unused or unnecessary columns from the data. So we'll learn how to do both of those things in RapidMiner. So drag the transactions and product data sets onto, so we did that, add the join, connect all the operators, specify the parameters for the join. We did that over here. And then let's go on to next. Now they say that the term attribute is lingo for column. In machine learning, each row of a data set is called an example. So if we go back to here, so this has this attribute, this attribute, this attribute, this attribute, this one, and now we've created a new one. We didn't finish, but, and then each row is called an example. Sometimes we'll call it an element of the data set, or sometimes we use the word instance in the data set. But in here, or in RapidMiner, they're using the word example. Which of these columns have numeric values or numbers? So obviously this one is not numeric, right? The values are male and female. And these are people's names, those are not numbers. And number of siblings, I'm sorry, and age, well, that is of course a number. And this is a number, and this is a number, and ticket looks like a number, but usually, we don't treat ticket numbers like they're actually numbers. Like we don't add these, we don't multiply them, we don't divide them, we don't subtract them. So sometimes things are coded as numbers. That is, they're written as numbers, but we don't use them the way we use numbers. So, this is more like a name than a number. Okay, just like this is a name, female is we call it, we say it's a name. Male is a name. It's not a number. And these are, they have some properties of numbers, maybe. I'm not sure, actually. Actually, I don't know about that. Maybe they don't. So maybe these are not numbers in any sense. And then these are certainly not numbers. The port of embarkation and the lifeboat number, that these are numbers, but again, we don't add the number like lifeboat number 2 and lifeboat number 11. We don't add those, right? And say, oh, if there's something, 13 means something. No, 13 doesn't mean anything in regard to lifeboat number 2 and lifeboat number 11. So I would say these are not really numbers either. And then survived, yes or no? No, those are not numbers. Okay, so some of the data, some of the columns, some of the variables, some of the attributes are numbers, but some of them aren't. Now, the thing is that in data science, whether something's a number or not, or in statistics as well, whether something's a number or not is important, because we have to treat data that has numbers in it differently than we treat data that doesn't have numbers. Like we just said, you could find the average age, which means we have to we have to add up these numbers. So we can add these, but we can't add these. You can't add male and female. You can't add this name and this name. So we can't do certain things with variables that are like names, or we also call them categorical variables, or I think in this RapidMiner they call them nominal, and sometimes polynomial or polynomial. But that's a peculiar, I don't know, maybe that's a German word because RapidMiner comes out of Germany. Maybe that's the word in Germany for nominal. But in English, we usually call them nominal variables or categorical variables, right? This is that sex is a category. So you're a female, that's one category, and male is another one. Or here, Southampton is one category, Cherbourg is another, and so on. Okay, so those are called categorical variables. They're called nominal variable, which just means name, comes from the Latin word nom, something nominal or something like that. And so this is called categorical or nominal, but these are numeric. So this is going to be important throughout working with data. Whenever you're working with data, you're always going to have to know whether you're working with numeric data or not, because you can't do the same things with things that are numbers and things that are not numbers. In fact, in high school, we rarely ever encounter or talk about, or we really very rarely learn about non-numeric variables. So here's a variable, those would be, and here's another variable. Those are numeric, and those are the kinds of variables we learn about in high school. And we never really even deal with non-numeric, like gender or sex. And so we don't deal with that. So we have to, so it's clear that probably we need to treat numeric data differently than non-numeric data. Okay, so that was a long rant. But you do need to be aware of this. It's very important to be aware of it. Okay, so one more thing I want to say about that, and that is, what do we say about this variable here, passenger class? So you might say, well, these are names, first class, second class, I guess is somewhere, and I don't know how many classes they have, but these are names. Maybe we can see that here. Let's see. Passenger class, if we expand that, there's third, first, and second, I guess. So there are three possibilities. So they call this polynomial or polynomial. Anyway, the main part of this is nominal, which means it comes from names. So anyway, going back to this, here, here. So these are nominal. Now we said like nominal, we can't add them, we can't subtract them, we can't multiply them. But there's another feature of numbers, besides being able to multiply, add, subtract, and so on, and that is to order them. So you can put things in order when you have age. So you can say who's the youngest person, the second youngest person, the third youngest person, and so on. So you can put them in an order. And the same thing with these and these, you can put them in order. Anything else here, obviously? I guess the prices we can certainly put in order. The ticket numbers, of course, we can put them in order, I guess, but it doesn't really mean anything, I assume, or it doesn't mean too much. So numbers, we can order them, and that's another kind of property that tells us that we're dealing with something having to do with numbers. But male and female, hopefully we can't order them. But here, passenger class, actually, there is a kind of natural order. Like we usually would think, well, first class is better than second class, and second class is better than third class. So there is a kind of order here. So it's, if we end up just treating this as nominal data, or as they say here, polynomial data, then, by the way, what's the difference between nominal and polynomial in rapid minor? So this is nominal. There are only two possible values, and when you have, but they're not numeric. When you have more than two possible non-numeric values, we call it they call it polynomial. So anyway, so here there is a kind of order. So this does sort of have a numeric kind of property because there's order there. But and if we just treat this as though there's no order at all, in other words, if we just treat it as nominal data, then we're sort of throwing out that information that's embedded in here, that first is better than second is better than third. But maybe we'll talk about that a little bit more detail later. Okay, so going back to here, they want us to do something called discretize. So let's keep going. To learn about building predictive models, let's go back to the Titanic data from earlier. This data is somewhat simpler than, I guess, the transactions and product data that we were looking at before, and does not need a lot of preparation. So remember, we created a new column in transactions and product and so on. we had to do the join, we had to do a lot more preparation, and here apparently we're not going to have to do much preparation. But we still need to specify which column we want to predict. So that's one thing we do need to do. So let's go back and look at it again. Here's the results. So we could say, well, we're going to build a model to predict how old people are, or we're going to build a model to predict how much they would pay for a ticket. So all of those would be, both of those would be maybe interesting to do. Maybe we'd like to predict how much someone would pay for a ticket, but that's not what they're going to do in this example. They're going to try to predict whether the passenger will survive or not. Okay, so that's the variable that we're trying to predict. This is a very important concept in data science. And when I teach this to students at university, I usually let them go out and find their own data set and then do all kinds of manipulations and so on and build models to predict something. But often at the beginning, students are not really clear that they need to predict something, and they need to identify a variable to predict. And then they also need to think carefully about that variable. And what I mean by carefully is they need to think, is it a numeric variable or a non-numeric variable? Because we're going to learn about different machine learning algorithms that we can use to make these models. And some of them work for the variable being predicted is numeric, and they don't work if the variable being predicted is non-numeric, and vice versa. Some of them work only for non-numeric variables that are predicted. We call those variables a variable that's going to be predicted. We can call it the output variable. So if this is what we're trying to predict, we might call survived the output variable. So the output variable may be numeric or it may not be numeric. But different algorithms work in different ways. Maybe some algorithms only work when you're predicting a non-numeric variable. Okay, let's go back. This data is somewhat simpler and does not need a lot of preparation, but we still need to specify which column we want to predict. So drag the Titanic data on into the process. Now hover the mouse over the output port of the retrieve operator and wait for a small window to pop up and display some metadata about the Titanic data set. So going back to here, what they mean is just do this. I guess maybe we have to do this here. Oh, there. So you can see some information. They call it metadata. It's sort of information about the data. So you can see like that passenger is what they call polynomial. Name is polynomial. Sex is binomial, means there's only two possible values, male and female. Age is a number. They call it a real. Means like a real number. Integer and so on. Anyway, this is, you can see this meta data. It's the kind of data about the data. Okay. Some of the information you know from the statistics tab. Note the two columns role and type in the table at the bottom. So I guess they mean what? I'm not sure. Okay, let's try that again. Now they say press F3 for focus. So let's try that, F3. So now this stays here. And I guess they mean role and type. So we've been talking about type, the type of variable. And then the role, there's no role. So role is going to be that one of them is going to be the output variable. One of these variables is going to be the variable that we're trying to predict. Okay. All right, let's continue. So they explain here, each attribute has a type which defines the possible values or the column. For example, if the values can be nominal or numeric. Okay, then also the role of an attribute describes how the column is used by machine learning operators. Attributes without any role, also called regular attributes, are used as input for training, while ID attributes are usually ignored by modeling algorithms because they are only used as unique identifiers of observations of data. So I guess what they mean here is F3. We don't really have ID variable in this case, but we did in the last case here. We had the product, actually no, not that, but like the row number. We've seen the row number come up in some of the work we've done in RapidMiner, and the row number is really just kind of useless for modeling. It doesn't give you any information. Like if you're trying to predict something, the row number shouldn't really help you in any way. Okay, let's continue. Okay, the next thing they said is we're going to do this one. Add a discretize by binning. So let's see what that looks like. Let's look for that. Okay, so discretize by binning is here, and we can drag that up here. So I guess there are other discretize by size and so on. But okay, so what does this mean? Well, what it means is we're going to apply this to the age variable. So let's go back and look at Excel. It's a nice view. Oops, that's the wrong one. Let's undo that. Let's remember how we can write this to an Excel file. So what you should try to remember what you need to do to write this to an Excel file. So hopefully you recall that you can do export and find read Excel and put that up here, and then connect this to here, and then sorry, that's wrong. We don't want to read Excel. We want to export write Excel. Okay, and then we can connect here to here. And then remember that, as I said, it took me a long time to learn this, but just do this. And then you can decide the folder. And we'll call this Titanic. And open it. And hopefully this will work. And then if we want to look at this in Excel, we have it here. Now, it looks like, remember that the lifeboat was, sometimes there was no lifeboat. So this is like Excel's saying that these are, anyway, it's just giving us a little note that this is a little different than this. Something's maybe wrong. Anyway, so ignoring these little green triangles for now, and going to this variable age. Okay, so what they're going to do, and this could be useful, but it's not necessarily useful, and it's not so clear why they're doing this right now. But what you can do if you want to is you can change this age variable, which is certainly numeric at the current time. You can change it into a non-numeric variable. Well, what does that mean? Well, it means that you could recode it using these, young, middle, and old. So like somebody whose age is 29 might be middle, and somebody whose age is 48 might fall into the old category, and 63 might fall into the old category, and so on. So you could recode this. So instead of putting 29, you could write middle here. Instead of putting 0.9, which I guess is a young baby, you would write young here. And this would be 2-year-old, and you would write young there. And this might be middle, and this might be middle, and so on. So you could just recode this. And that's what they're doing. they're going to recode this so that instead of these numbers, we're going to have young, middle, and old. Now we said that young, middle, and old do have some properties, some numeric sense about them, because young is, sort of comes before middle, and middle comes before old, right? So there's an order here. So there is that's a kind of property of numbers, that there's an ordering. And so it's not really the same as like male and female where there's no order, or these people's names where there's no order, or this where there's no order. So here there's some kind of order. So it's a little bit different sort of than just strictly non-numeric data. So we just want to keep that in mind, perhaps for later. But anyway, we want to recode this. And that recoding, when you take a numeric variable and you recode it to a nominal, or they might call it polynomial because there's 3, not just 2. But anyway, I'll call it nominal, and this should be numeric. When you do that, it's often called binning, because you're creating bins. So you're creating bins. So this would be young, middle, and old. And you're going to take anybody whose age is like whatever, less than 15, and you're going to put them in here. And anybody whose age is something else, you're going to put them in here. And anybody whose age is the other, you're going to put them in here. So we're kind of putting them in different bins. So it's often called binning. So that's what we're going to do next. Or it's also called discretizing, because you're taking a number and you're making it into a discrete value. So it's also called discretize by binning. Okay, so that's what we want to do. So let's go through the steps. So let's get rid of this because we don't need that. And we need the discretize by binning. And that's here. And we have to connect this. So then they say select the attribute filter type to single. They say because we're only going to be working on one of the attributes. I guess we're only working on age. So that's why we set it to single. So let's try that, single. And set the attribute to age. So we have to decide which variable we're working on, or we're going to work with. So it's the age variable. And set the number of bins. So when I just showed you those 3 bins, I decided to make it just 3 bins. So just young, middle, and old. But you could have changed it to young, sort of young, middle, sort of old, and old, or whatever. But anyway, here they say number of bins, and they want us to use 3 bins. Okay. And they tell us binning is a common technique to transform the type from numeric to polynomial, a nominal with more than 2 values. Here we create 3 bins covering the complete range of values. The operator then, so that just means that we're going to basically every value of the age will be put into one of the bins. The operator then replaces the original numeric value with the name of the bin the value belongs to. This technique is often useful to categorize data into simpler to assess groups. Like everything bigger than x equals something is called interesting, and everything smaller than x equals something is called not interesting. Or you might take student grades and categorize them as pass or fail, depending on like whether they do better than 60 or not. So everything greater than 60 is pass. Everything less than 60 is fail. Such groups can then be used in calculation, charts, or even serve as a label for model training. So we don't know what that means. That we haven't talked about that yet. I don't know why they put that in here, but maybe they assume that you have some knowledge already. Okay, so anyway, let's go to the next. Okay, so the next thing is we need to set roles. So let's get that operator. And here's where we decide, or we tell RapidMiner what we want to predict. And we're going to predict, as we just mentioned earlier, whether people survive or not. Okay, so they say connect it. In the parameters for attribute name, so here we'll say survived. Okay, and then they say change the target role to label. So remember that survived is the variable that we're going to try and predict, or the attribute that we're trying to predict, or the thing that we're trying to predict. And so I called it the output variable, and that's a common way to talk about it. But you can also call it the label for the data. So instead of calling it the output variable, you can call it the label. So that's another word that's used sometimes to indicate which variable is being predicted. So here we'll set the target role to label. And then they tell us to run it, but we better do this first. And let's see. So hopefully, I think the main thing that's going to happen here is that age is going to have, well, let's see what it looks like. Let's run it. Okay, so age is no longer, we don't have ages here. This doesn't look like what we had before. These are not ages. But what it did do, as we said, was it made bins, and we can see that here's a bin. If you can read that, it says minus infinity to 26. So that means basically 0, right? Age can't be minus infinity, but age could be close to 0. So 0 to 26 point something. So that's probably the first bin, and or what we would have called young. And then 26 to 53 is another one of these possibilities, and that's probably what we would call middle. And then here, 53 to infinity is going to be older. Okay, so, and I think that's all the only kinds of things that are here. There are only those three, and these are the three different categories that it made up. So basically, where did this number come from? And where does this number come from? And so on. Well, what it does is it just takes the original data, remember it was age, and here it is, and it just chooses, it takes the largest value in age, which of course you can get like this. I guess you can go equals min, and then just go from here down to the bottom. Okay, here, and put that in there, get the minimum. So the youngest person in this data set is that. There's a very young baby there. And I guess I could label this as min, and we can also do max by doing this. I can copy this as long as I put these in front, if you know about that. So I can just copy this and then change it from min to max. So now I have the max function. So the oldest person in this data set is 80. So I guess all they did is they took the interval from 80 to 0.2 and they divided it into 3 equal widths. I'm not sure if that's what they did, but that's certainly one thing you could do. Is you could just take, so what is that? That's 79. The range from the smallest to the largest is 79.8. And then just divide 79.8 into 3. Let's see what that gives us. Well, anyway, it's not important. Well, let's see what happens. So let's see. This is 79.8, and we divide it by 3. We divide it by 3, and we get 26.6. And then if we go from 0.2 and we move up 1/3, so if we take 0.2 and we add 1/3 of the length that is this to it, I guess we'll probably get to the number they had, 26.7667. Is that what they had? Yeah, something like that. So that's probably what they did. So anyway, they just put it into bins. And there are different ways to select the bins and so on. But the point is that they wanted to put them into bins. So these are not numbers anymore. We could call this middle, and we could call this young, and we could call another one of them old. So they're really nominal. But as I said, they're a little bit more than nominal because they do have an order to them. But here it looks like they're going to be treating them as nominal. Okay, and then they say, look at the statistics tab in the results view, and note the role of survived has changed to label. So survived is the output. Seems like it also moved it because I think it was over on the right before, and now it moved it over here. So I guess after doing this, it puts the label or the output variable first. This doesn't really count, this variable or this column. I wouldn't even call this a variable. I would just call it a column. Okay, so let's look at the statistics. And here it calls it label. You can see label there. Okay, so that's the label or the output variable. So you have to tell RapidMiner what it is that you're trying to predict. It doesn't know because you have many choices. So you have to say what it is that you're going to predict, and this is how you do it. You do it by setting the role here. They also say the attribute age also has a new type. Now the numeric values for age have been replaced by new names. So let's just check that again. So age is called least, most, and I don't know what else. No, I guess it's not called least and most. But anyway, we have ranges, like we said before. And now it's nominal. Now, just as a personal warning, at least maybe they deal with this. There are probably some ways to deal with this, but the fact that it's nominal here is a little bit of a pity, because if we throw out the fact that there's some order there, that is unfortunate, because order is information, and we don't really want to throw away information when we're doing data science. So they say, great work. Setting an attribute role is useful for many things. For example, identifying ID-like attributes or example weights. So I guess what they mean by ID-like attributes are here. This is like an ID. It's sort of useless data. Okay. But the most frequent use is to define the label, i.e. which attribute should be predicted based on the other attributes or based on the input attributes. Okay, we'll go to the next tutorial.